So last class we started talking about our series. So we moved from sequences with just a list of numbers that had some kind of a pattern to them. We moved into series, which was taking those list of numbers and just adding the values together. That's what made it a series. So now we're going to go into summation notation. Summation notation goes along with your series because all a summation is doing is adding terms together. And it has a symbol to help you figure out what it's doing. So this little funky E guy here, that is called a sigma. That is a Greek letter. That is the sigma letter. That just is what we use to stand for summation. So it gives you some variable that you're plugging into. They like to use the letter I a lot, so it's not I as we know it to be the square root of -1. I in this case is just representing some kind of a variable, so it's kind of like an X or an N at that point in time. So it tells you I equals some number, and that number is our starting value. And so what we do is we take that number and we plug it in for the I in this portion of it. This is your formula. And then that number on the top tells you where to stop plugging into. So you're going to plug in the first number on the bottom, and then you plug in the next number, and then you plug in the next number until you get to whatever the number is up on the top, and that's when you stop and actually add your values together. So let's take a look at our first example. We have I equals 3, all the way 5 up on the top, and then our formula here is a 2I. So that means we're going to start with the 3, and we're going to plug that in for I in the formula next to our sigma sign there. So that would become 2 times 3. And then we would plug in the next number, so then we would also plug in a 4. And then we would plug in a 5. And 5 is my number up top there, so that's where I'm going to stop. I'm not going to plug in any other numbers now. And now we just simplify. So 2 times 3 gives me 6. 2 times 4 gives me 8. 2 times 5 gives us 10. So then 6 plus 8 plus 10 gives us 24. So you just start with the number on the bottom, plug it in, plug in each number until you get to the one on the top. So for letter B here, k equals -1, so we're starting with a -1. We're plugging it in for our k, so that means it's going to be -1 squared, and then 0 squared, 1 squared, 2 squared, stopping at 3 squared, because 3 is our number up top. So again, now we just simplify. -1 squared gives us a 1. 0 squared is 0. 1. 2 squared is 4. 3 squared gives us 9. Add them all together, what do we get? 15. So this time for letter C though, letter C, when we're plugging in for the variable, what is it? It's the exponent. So that means we would start with 2 to the -2, because on the bottom of my sigma sign there, it's telling me to start with a -2. And then 2 to the -1, 2 to the 0, 2 to the 1, and then 2 to the second. And that's where we're going to stop, because the number up top is a +2. So 2 to the -2 gives us 1/4. And then 1/2, and then +1, +2, and then +4. So what do we end up with as our final answer? 7 3/4, 7.75. Let's have you go ahead, try letter D. See if you can do that one on your own. So again, I know the symbol looks scary, but it's really not that bad. You're just plugging in, adding the values after you've done your plugging in there. So number 2 down here. Which of the following represents the value of the summation going from 1 to 4 of 1/I? There is a way to do this in your calculator. So we go to our calculator. if you hit alpha window, you should get this little table of options. Alpha window. And then if you look there, choice number 2, that is your summation sign. So you would select that second option in there. I recommend just using X in the calculator. Don't go finding the letter that it is that it's using. Just use X as your variable. So this one is starting at a 1. So I got X equals 1 on the bottom. I arrow up to the top where I'm going to put a 4. So then for my equation, it's going to be 1 over X. And then we can hit enter and it gives you your summation there. So 25 over 12. Calculator can help you out with that if you need it. So our next example here, it says consider the sequence defined recursively by this. And it gives us our first 2 terms. Our first term is a 0, our second term is a 1. Let's look at what the recursive formula is saying. So again, what does a sub n minus 1 represent? Previous. And then what does n minus 2 tell us? Yeah, it's like the previous. You got to go back 2. That's why they're subtracting 2. So n minus 1, that's like yesterday. And then n minus 2 would be Wednesdays. That's 2 days before. So you're going back 2 terms there. So you're taking your previous term and then you're doing 2 times the previous term. And that's how you're figuring out your current term. So looking at our summation sign here, we're starting at the 4th term, going up to the 7th term. And all they're telling us to do is to plug it into that recursive definition there. But can I figure out my 4th term yet of my recursive definition? No, I got to figure out my 3rd one. So since I'm figuring out that one, all I'm going to do is I'm going to figure out my first 7 terms because I have to get up to number 7 anyway, so I might as well just, since I'm doing it once, keep going with it. So my 3rd term would be the term before it, so my 2nd term, which is a 1, plus 2 times the 1st term. So what does that give us? We get a 1. Now I'm just going to separate it because now, starting with my 4th term, I'm going to need this for my summation over there. So my 4th term is the 1 before it, so my 3rd term plus 2 times my 2nd term, because I got to go 2 terms before the 4th one. What does that give us for a 4th term? Should get 3. So then my 5th term is my 4th term plus 2 times my 3rd term. So that gives us a 5. My 6th term is my 5th term plus 2 times my 4th term. So that gives me 6, 11. So my 7th is my 6th term plus 2 times my 5th term. So that gives me 21. So we did all our work, figured out what our terms were up to number 7. So again, our summation wants us to add our 4th term up through our 7th term. So 3 plus 5 plus 11 plus 21. So what does that give us? 40. Sometimes they throw you for that loop where you got to figure out that recursive definition. Now you should be able to go backwards. You should be able to take a series and create the summation equation that goes along with it. I will tell you, there's more than one equation that's going to work. There's not just one right answer for these. You could come up with a very different equation that I come up with. So keep that in mind when you're doing your homework, if you're checking your answer key. Just because yours doesn't match mine doesn't mean you're wrong. It just means you came up with a different one than I did. So looking at letter A, I'm going to draw on my little sigma. You can use any letter you want normally, but this time they told us to use I. I'm going to go ahead and use I as my variable here. So let's take a look at our series that we have. I have 9, 16, 25. I'm ending at 100. I'm noticing that these are kind of specific kinds of numbers. What kind of numbers are these? Perfect squares. So what is the square root of 9? 3. So I would say that this starts at 3. And where would it end? 10. And I'm just squaring my variable, so I squared. Okay, letter B. We got -6, -3, 0, 3, ... 15. Again, more than one equation here. Anybody noticing any kind of a pattern? Adding 3. So that tells us it's kind of looking like what kind of a sequence? Kind of looking like an arithmetic. So we can use that to help us figure out our formula. Our common difference would be a 3. We could say our first term is what? -6. So if I do -6 plus 3 times my n minus 1, I don't really know what my n is. So do we know which term 15 would end up being? No, but do we really need that? We will in a second. But so let's figure this out. Distribute our 3. And we would end up with 3n minus 9 as our explicit formula. Now, you have to put it in parentheses. Because if you don't put it in parentheses, let's say you left it like this, you are saying all you're going to do is plug in your number into the 3n, add those together, and then your whole answer would be minus 9. This minus 9 right now is looking like it's after you've taken the summation. So after you've added everything together, you would be subtracting 9. Putting it in parentheses like this is saying you have to do that for each term, is 3n minus 9. So we're going to start at 1. We said our -6 was our first term, so that's going to be a 1. We have to figure out which term is our 15. So if I do my little explicit formula that we just found and set it equal to 15, we can figure out where our summation needs to stop. So plus 9, that's 26, divided by 3, what do we get? Must be an 8. It would be 24 divided by 3, so 8. So those other sequence formulas can still help you figure out these equations if you need them to. So letter C here, 1 over 25 plus 1 over 5 plus 1 plus 5, ... 625. What kind of a pattern do we have here? Multiplying by 5, so that tells us it's a what? Geometric. Okay. So again, if we go with our formula, we're going to want our bottom number to start at 1, because we're going to say 1 over 25. We're going to say that's our first term. We already figured out the r is 5. We said we were multiplying by 5. That's how we knew it was geometric. So I'm just continuing on with my formula. It would be to be n minus 1. Actually, that should be I, because I used I down there. I just remembered that. So for this one, that could be one of our formulas that we use. There's a few other formulas we could have used. This could have been one of them. So then we just have to figure out where is our summation going to stop. what term would give us 625? Let's see here. 1, 2, 3, 4. If I do times 5, that'd be my fifth times 5. Times 5. There we go. 625 would be my seventh term. Or you could do like we did the last time. Take this, set it equal to 625, and then solve. You probably end up having to do logs on that one. Okay, let's take a look at number 5. So we have 3, 6, 12, 24, 48. They want us to figure out which summation is going to give us that sequence. So first off, we have how many numbers here? We got 5 numbers. So if I'm looking at just my top and my bottom, 1 to 5, that would work. That would be 5 numbers. 0 to 4, that would also be 5 numbers. 0 to 4 again, that would work, but 3 to 48, that's not going to work, because I don't want 3 to 48. That's too many numbers, so I've got to at least narrow down a little bit. So now we'll just try it. Starting with choice number 1, if I plug in a 1, 3 to the first is 3, but then if I plug in my 2, is 3 to the second 6? No. Well, it's not going to be that one. So how about if we look at choice 2? I'm kind of thinking it's choice 2. Because what are they multiplying by each time? 2, and I got that 2 there. So that's making me think it's probably going to be that one. So if we plug in a 0, 2 to the 0 is 1, times 3 is 3. If I plug in a 1, do I get a 6? Yep, because 2 to the first times 3 would be 6. If I plug in a 2, do I get 12? Yeah. So it's going to be that one. So you just have to start looking at your different terms, see if it works out. And then our last one down here, we got some sums are a little bit more interesting than other ones. So for this one, what we have is this formula right here. Determine the value of this and then show your reasoning. So what number do they want us to start plugging in? 1. So if I plug in a 1, I get 1 over 1 minus 1 over 2. Which really, what does 1 over 1 equal? So I can just leave that as a 1. So I plug in my next number. I'm going to plug in a 2. So if I plug in a 2, I get 1 over 2 minus 1 over 3. So if I plug in 3, I get 1 over 3 minus 1 over 4. Now I'm not going to actually keep adding until I get to the 99th term, so I'm not plugging this in 99 times. But let's look at our pattern. Negative 1/2 plus 1/2. What's going to happen there? They're going to cancel each other out. Negative 1/3 plus 1/3. Cancels. So my negative 1/4, that's going to cancel with my next term, which is going to start off with a positive 1/4. That'll end up canceling. So if I get to my last term then, plugging in my 99, I would have 1 over 99 minus 1 over 100. But for my 98th term, I would have had my negative 1 over 99. So that would cancel. So then we're left with 1 minus 1 over 100. Which would give us 9,900. So that's called the telescoping series. It's kind of like a telescope. If you stretch it out, you have this whole stuff, but it also condenses down, becomes nice and short. Same thing happens here. Everything cancels, so it just condenses down, and you're left with the beginning and the last one. I know all of you are dying to go get mortgages. So mortgages, not just on houses, are large amounts of money borrowed from a bank on which interest is calculated, added on a regular, typically monthly basis. So generally, when they say a mortgage, they are referring to a house, but you can also take mortgages out on other things. It's just not as commonly known. But you're just taking out a huge lump sum of money. So regular payments are also made on the amount of money owed, so that over time the principal, which is the amount of money you initially borrowed, is paid off, as well as any interest owed, or any interest on the amount owed. This is a complex problem that ultimately involves geometric series. It ends up becoming a series problem, and we're going to walk through this. So let's first start off with making sure you understand what's happening with our mortgage. So let's say a person takes out a mortgage of $200,000. They're going to make monthly payments of $1,600, and the bank's going to charge them a yearly interest rate of 4%, which actually is pretty accurate right now. It's about 4% interest on a mortgage right now. So what is the amount owed at the end of the first month? Show the calculations that lead to your answer. So this is going to be connected back to this formula, which we first learned in exponential functions. We then talked about it again in logarithmic functions, and here it is yet again in our series unit. So this would figure out how much money is owed over the entire life of your mortgage, and that's how they phrase it. It's the life of your mortgage. But since they want us to just look at 1 month of this 30-year mortgage, we don't need the exponent. We don't need to know the entire life of it. We're just looking at 1 month of it. So our P, that's how much money that they initially borrowed. $200,000. R would be 0.04 because it is 4% interest. And then we would divide it by 12 because, again, we're just looking at 1 month of it, not the whole year's worth of interest. So go ahead, type that in your calculator. Let's see what we get. And remember, we're dealing with money, so 2 numbers after that decimal. So you should get $200,666.67. Let's make sure we understand. That's $666.67 in interest in 1 month. That is how much interest they're charged for 1 month. So now to actually figure out how much is left for them to pay, we subtract now their monthly payment. So after 1 month, they still owe that much money. $199,066.67. So now let's take a look. Of that $1,600 monthly payment that we made, let's figure how much of it came off of the principal, which, remember again, the amount of money they initially borrowed. So $200,000 minus what was left at the end of the first month. How much of that $1,600 actually went to their principal value? Hopefully you got 933.33. So then the amount towards interest, take your payment subtract how much of that went to the principal value. And they paid $666.67 in interest. And then on top of that, you still got your school taxes, your property taxes, your county taxes. So your monthly payment's even higher, really, than $1,600. Crazy. So now, part C, they want us to determine the amount owed at the end of the second month. Again, show the calculations that lead to your answer. So this time we're looking at the end of the second month. So my initial value that I'm multiplying interest by is not going to be the $200,000 because I've made one payment. So I'm going to take how much was there at the end of the first month, multiply it by the interest for 1 month, so the 1 plus the 0.04 divided by 12, and then subtract my monthly payment to figure out how much is left now after a second payment. So after your second month, you should have $198,130.23. And then it just keeps going on and on and on like that. So this time it went down about $900 again, a little bit over $900. So you still end up paying a ton in interest. So the amount owed at the end of each month, it actually starts to form a sequence. And the sequence is written recursively. So the first amount, A sub 1, your first term is always whatever your mortgage amount is. So in this case, $200,000. Each month after that is the previous month. So A sub n minus 1. 1 plus 0.04 divided by 12 minus the 1,600. So again, that value changes a little bit depending on what your interest is and what your monthly payment actually ends up being. So that 0.04 and then that 1,600 will change based on your terms and agreements. So that's the way it ends up going. I mean, the nice thing is towards the end of your mortgage, you're paying more towards the principal than you are to interest. Interest is always very heavy at the beginning of your mortgage than it is towards the end of your mortgage, but it's still there. That's why mortgages are 15 to 30 years. Okay, let's take a look at this again. Next one. So now we're going to switch it up. This person has a $150,000 mortgage at a 5% yearly interest. So clearly their credit score was not as good as the first person because their interest is higher. That's the way it works. Why would it be unwise to make monthly payments of only $500? Let's figure out what's going on here. So following along, the same idea we had last time. Take our mortgage, $150,000. We're going to multiply it by the interest for 1 month. This time, though, it's going to be 0.05 as our R because they have 5% interest versus the 4. And then we would subtract their monthly payment of $500. So let's see what we get. You get 150,000, 125. So what's happening? Why is 500 not a good amount? Yeah. Yeah, they didn't even pay off the interest yet. and they didn't take anything off of the principal. So the fact that it went up means they didn't even cover the interest. So they definitely are going to have to pay more than $500. Or if $500 is what they want to pay, they're going to have to get a smaller mortgage. All right. So now these mortgage payments, it's pretty easy to find them recursively because you just keep taking them month before it, multiply it times your interest, subtract your monthly payment. And you can just keep doing that over and over and over again. But again, with a 30-year mortgage, you'd have to do that 360 times. Nobody really wants to do that 360 times. So you can write the formula explicitly so that you can figure out any term that you want to, so you can look at it at any point in time. It is a little trickier though. So let's go back to our example, $200,000 mortgage, 4% interest, $1,600 monthly payments, which again covers part of the interest and the principal value. So when I say down here, if I say the letter R, that's representing our interest. P is the 200,000, M represents my monthly payment. So when you see those letters, that's what those are representing down here. So part A, explain what the following calculation represents. P times 1 plus R minus M. What is this representing here? Yep. Amount after 1 month. So you took your principal, it's multiplied by the 1 plus R, that's you multiplying it by the interest, and then subtracting your monthly payment. So that's how much is going to be left after 1 month. So now part B, what does this calculation represent? This stuff here in the first parenthesis that is our first month. Before, when it's recursively, we can write it as a sub n minus 1. It makes it a little nicer to see. But this way, that is our first month. P times 1 plus R minus your M. So then this right here is the second month, of interest and payment. So that 1 plus R is being multiplied by the previous month, and then I'm subtracting my monthly payment here. So they want us to write this in expanded form, but leave the binomial of 1 plus R. So if I take this, which is all one term, P times the 1 plus R, I would have to multiply it times the 1 plus R. So it would become P times 1 plus R squared, because you have 1 plus R from the first one, times itself again, so it's going to be squared. So then, because I'm just basically doing my distributive property here, I'd have to do this 1 plus R, also times that minus M from the first month. And then we would be left with that minus M. So this minus M times 1 plus R, that's representing the payment from the first month. This M here is representing the payment from the second month. So that's how those are being deferred there. So then if we were to continue this formula, so this is your formula to figure out your second month. If we were to continue that to figure out the third month, the P times 1 plus R would then go to the third power because it's now the third month. so you'd have to multiply the principal times the rate a third time. This payment here again, which was from the first month, when I get to the third one, is now 2 months ago. So it'd be squared now. The payment from my second month, which is this one here, would now have to be times the 1 plus r. And then I would end it with the payment from month 3. So now this is the payment from month 1, which was 2 months ago. The payment from month 2, which was now 1 month ago. And then this is my payment from this current month, month number 3. So then for month 4, b times 1 plus r to the 4th, whatever month that is, that's raised to that power. What would happen to this one? What would happen to that exponent? It would become a 3 because now that payment, which again was from the first month, was 3 months ago. The exponent on this one would become what? Squared, because now that payment was 2 months ago. This one would have to be multiplied by 1 plus r, because now that was a month ago. And then I'd need a new minus m for this current month. So if you notice, we just keep adding on to this part right here. So month 5, I'd have this one to the 4th, this one would be to the 3rd, this one would be squared, this one would be times 1 plus r, and then there'd be another minus m at the end. So it just keeps expanding itself that way. So based on part C, write an equation for how much would be owed after n months. So the first part's a little easier. P times 1 plus r to the n. That's how we would start off. So that would be minus a monthly payment times 1 plus r to the n minus 1. It's 1 less than whatever this one is. Minus m times 1 plus r to the n minus 2. That one would be 1 less. Dot, dot, dot. Until that one became to the first power. And then minus your last one. So that's just each monthly payment and working its way down to the one that you're currently in. Is your monthly payments end up becoming the geometric series. The first part where you're taking the principal and multiplying it times the rate, that's not the series portion. It's your monthly payments. That's what ends up creating the series. So this right here is what I just wrote up there. Only it's a little easier to type and a little neater sometimes than my handwriting. So first month, second month, third month, all the way down until you get to whatever current month that you're actually in. So what I did is I first factored a -1, and then I switched my order. And that got me there. So I turned everything positive now by factoring out a -1. And I used that commutative property and I just changed my order so that my m at the end is now first, and then that one's second, so on and so forth. So it looks a little bit more like a series that we're used to seeing. So now find the sum of the geometric series inside the parentheses. Think carefully about how the number of terms in this expression. So our geometric series formula is that. So if we look at our series inside the parentheses here, starting with m and so on and so forth, my first term is m because that's the way I rearranged it. My rate is 1 plus r. Okay, so our rate is the 1 plus r. All goes together because you got to do 1 plus your rate. And then 1 minus 1 plus the rate. So that is our series formula there for the monthly payments. So to actually figure out how much you owe at some random point in time. So this one wants to know how much is owed on the loan after 10 years, which would be 120 payments because it's 12 payments a year for 10 years. Because again, I'm doing an explicit technically still, so a sub 120. We would start off with our principal amount, which was 200,000. Times 1 plus 0.04 divided by 12 to the 120. Because again, we're going for 10 years, 120 payments. Minus, and now we're going to go to this part. We got to use that for our monthly payments that we're subtracting. How much was one monthly payment? 1,600 minus 1. So we had to use a series to help us figure out an explicit formula for this one to figure out any payment. We're looking for after 10 years, how much is left on that mortgage. Let's get that number, $62,566 and then 85 cents. Again, that's how much you have left after 10 years. You still have another 62,000, almost 63,000 to go. But with $1,600 of monthly payments, for 120 payments, you've paid $192,000. You should only have about $8,000 left. Because of that interest, you still have $62,000 left to go.